Hello, class. I want to apologize for again missing the Friday class, and I want to also let you know that my daughter's finally doing better. Thank God. Thank you for your prayers, and thank you for keeping us in mind. This lecture is for the chapter 4, and this is for section 4.5, which is the last section in this chapter, exponents, polynomials, and polynomial functions. The purpose of this section is to really teach us how to divide a polynomial by a monomial, how to divide one by a polynomial of 2 or more terms, and then how to divide polynomial functions in general. When we start with our first objective, we want to remember that a monomial is simply just one term. As you can see, we have a polynomial, two-term expression, and we're dividing it by one term. If we have this sort of a looking fraction, I know Eric is going to have a question about this. He doesn't like fractions, and some of you don't like fractions, but it's simply very easy if we follow the rules that when we have a plus sign or a minus sign in this term up here, dividing it by a monomial, we can separate it as long as we only have one term down here. We can separate it just like this, a over c plus b over c. And then we could write each quotient, each fraction in its lowest terms. And what that means is basically we're simplifying the fraction. So let's take a look at this. If I have this big expression up here and I'm dividing it by a monomial, which is 5 in this case, I can separate them into how many fractions here? 3 fractions. So in this case, I'm separating it into 1, 2, and 3. And then, of course, this is not the lowest term, so I can simplify it even further. 10 divided by 5 is 2. 25 divided by 5 is 5. And then 35 divided by 5 is 7. So this is what makes it, makes this fraction to this, because I can simplify it by dividing each fraction, each term, by the monomial. And then also you could check your answer by multiplying it by 5. If you multiply each one by 5, each term by 5, you're going to end up getting this term right here. Okay, so this is the divisor, this is the quotient, and this is the original polynomial, which is the dividend. Here are some exercises for you to complete, and also please make sure that you submit those to class either tomorrow or Wednesday, whichever time works for you. I'm understanding that it could take a little bit of time for you to submit this work because this video is a little late, but make sure that you complete these before you look at the answer. So pause the video, complete the exercises. So these would be the answers, and they don't always have to be just one term, they could still be fractions as well. Now let's take a look at the second objective, where we're dividing a polynomial by a polynomial, in this case of 2 or more terms, and we're not just using one term. In this case, it's a little bit more difficult, just a couple more steps, but let's take a look at this sample problem right here, where we're dividing this expression by a polynomial that has 2 terms. So we are going to write the problem as if we're dividing it with whole numbers, and make sure that both polynomials are written in descending powers, which means you're first going to write the highest power, then the lowest power, and then the constant. And then you're going to use the traditional division method. So you're going to divide first the first term, which is 2k squared, by the first term of k plus 6. And then you're going to write the result above this line, just a traditional division. In this case, 2k squared divided by k plus 6 is equal to 2k. And then we're going to multiply the result below, which is 2k, by k plus 6. We multiply this by that, and then we're going to write it. And this will give us this expression right here. And then we're going to subtract, just like we do traditional division. Do this mentally by changing the signs of 2k squared plus 12k, and then adding, or you simply subtract. So subtracting 2k squared, that's going to give us 5k. Then we're going to bring down the 30 and then continue dividing 5k by k. This is going to be equal to k. And then finally, you're going to, so you brought down the 30 and then dividing the 5k by k, and then subtract both terms, and that's going to be equal to 0. You can check the results by simply multiplying 2k plus 5 by k plus 6. This is the traditional division, and practice a lot on this because it does take a lot. It's not a simple traditional division, so go ahead and make sure that you practice doing it for multiple problems. So again, you're going to write the polynomials in this example in descending order, just the way it's written, and add a term of 0 as a placeholder for the missing term, which in this case is x squared, because you see you go from x cubed to x. This is a special case right here, so you will write it as such. And then start with 4x cubed divided by x. That's equal to 4x squared, right? 4x squared. Then you're going to multiply the 4x squared by what? And this goes right above the x squared. You multiply it by x plus 2. This is going to be 4x cubed plus 8x squared. Okay, then you're going to subtract mentally by changing the signs of 4x cubed plus 8x squared and then adding, which means minus, minus, and then adding the 2. And then after we add or subtract, whichever way you want to look at it, we're going to get negative 8x squared. Bring down the next term, which is 3x. Then negative 8x squared, divide that by x. As you can see, it's going to be negative 8x. Do the multiplication and then subtract. Then multiply and then subtract. So if we multiply negative 8x by x plus 2, negative 8x squared, negative 16x, and then we're going to subtract the 2, or in other words, the way they are telling you to do it here is by just changing the sign and then adding. Either way, this will be 19x. Bring down the next term, which is negative 8, and then 19x, divide that by x. That's going to be 19, and multiply then subtract, you'll end up getting negative 46. Okay, so and when you have a 0 remainder, you don't add it, but when you have a number here, you're going to add it as such. So this is going to be 4x squared minus 8x plus 19, negative 46 over x plus 2. Going back to the previous example, if you remember, we ended up with, let's see, we ended up with a 0 remainder. In this case, we only had, it was only 2x plus 5, but in this problem, we had a negative 46, so we do have to add it at the end. Here's another sample problem that I suggest that you do that on your own. And show me the way that you did it, as well as the final answer. I'm going to go through it as well. So in this case, we are dividing this long expression here by m squared minus 5m. Again, you're going to add a 0 for the missing term, which is the constant here, and you're going to do each one. So 4m to the 4 divided by m squared, you're going to write that right above here, and you're going to do each one, and you're going to end up with an m minus 1 as a remainder, so you'll write that. Please do it on your own and show me. Make sure you don't look at the answer before. Look at the actual problem, do it, and then look at the answer, just to confirm that you know how to do it. Here's another sample exercise I want you to do on your own and submit as well. So those who are listening to the video will know that they need to submit this work. You might end up with some fractions in this case. In such a case, please make sure that you practice this and do it on your own. Write it before you look at the final answer. You're going to end up with a 0 remainder in this case, so you won't have to add anything at the end. The last objective is dividing polynomial functions, and in this case, if I have a function as denoted as f of x, another function denoted as g of x, and I'm going to divide them, the division of the two is called the quotient function, and the domain of this quotient function, which is this, not just one or the other, it's actually the intersection of the domains of the two. So it's not the union, it's the intersection. So it excludes any values for which g of x is equal to 0, because remember, this is the denominator. In this case, we cannot let this be equal to 0. So any value of x that would make g of x equal to 0, we exclude that from the domain. Please pay attention to that when you're doing the quotient function. It cannot be any value. It cannot be any intersection. It has to exclude these x values. So if I have a f of x, and this, we were doing these in the previous exercises, but this is more of a general picture of what we're what the exercises were leading us to, be able to know what a quotient function is, to evaluate that, and also to determine the domain. We are going to determine what f over g of x is, and then we're going to evaluate it at -1. So we conclude that this is from example 2. Okay, this divided by this is going to be equal to x plus 6. Then we're going to evaluate it, provided that the denominator, which is 2x plus 5, is different from 0. If this is what you do, you're going to end up with x plus 6. We did this example. Then you're going to evaluate at -1 simply by replacing the x by -1. So this is going to be equal to 5. What is the domain of this quotient function? Remember, it's any x value except for the value that makes 2x plus 5 equal to 0, which in this case it will be -5 over 2. You're going to divide this polynomial again, and this is the one I think that we just did, right? Example 2, which is the review for this previous problem. Thank you very much for listening. I will see you guys tomorrow, and we will continue working with our exercises. Please make sure that you review this video well, you review the contents from the previous class that we had, because you probably will have a quiz, and make sure that you submit these class problems. These will be considered your attendance to the video. Thank you very much for listening, and have a blessed Sunday.